All right. So what is a vector again?
It's direction and magnitude.
Okay, so it has direction and magnitude, right? Like Vector in the clip, he said he's gonna be evil with both direction and magnitude, right? A vector in physics, not just in a movie, okay, is a quantity that has both direction and magnitude. Anthony, you want the lights again for me? Thank you. So it's a quantity that has both direction and magnitude. It's a quantity that has both direction and magnitude. Okay. Now, anybody remember what the opposite of a vector is called? It's not really the opposite, but the counterpart to a vector? No. All right, we'll come back to it. Let's talk about this direction idea. No, wait, no, we're getting ahead of myself. What the character in the movie say a vector is? He says a mathematical quantity represented by a
Direction.
arrow, right? Has an arrow. So here I have two arrows, right?
Yeah.
We'll call this one vector A and this one vector B. Now they have the same starting point. Okay. Now I know they're vectors because what did I draw on top of them? Arrows, right? That means these little arrows mean that those letters A and B represent vectors. Okay. Now these two vectors A and B, they have two things going for them. They have a direction and a magnitude. The direction is what? What's the direction of A?
Right.
Okay, kind of to the right, a little bit up, right?
Yeah.
Right? What's the direction of B?
Right.
It's going up.
Okay, it's more up, but still to the right, right? So the direction is indicated by the way the arrow points. Right? The direction is indicated by the way the arrow points. Hello, Michael. You missed a cool video clip.
Your shirt looks fine. You look great. It's like talking in the back.
It's like you're talking to yourself. It's like you're talking to yourselves in a mirror right there. Thank you. So the direction is indicated by the way the arrow points, right? And what's the magnitude? What indicates the magnitude?
The point.
The length of the arrow. Good. So which vector up here has a greater magnitude?
A.
Which one? A has a greater magnitude. Why does A have a greater magnitude? Because the arrow is longer. Okay. So magnitude is represented by the length of the vector. So magnitude is represented by the length of the vector. So direction is the way the vector points. Magnitude is the length of the vector. Now, if I'm writing a sentence that includes a vector quantity in it, there are two ways you can represent it. You can either write the vector quantity in bold. Now, I don't have the bold function on my markers, so I'm just going to make a little darker. So if you see a bold letter, okay, that means the vector. Or if you see the letter with what? An arrow on top, okay? Both of those can indicate vectors. Now sometimes when I'm drawing on the board, I get a little lazy, and I just draw the arrow like this, with just one side of the arrow. That's fine too. So either bold letters or arrow on top, both of these mean vector. Completely up to you. These are your notes. Thank you. It's like we're always having a sword fight. They should say hi to the YouTube audience, bro. Almost called you Ralph. There you go. Nice job.
Most of your videos usually
Okay.
don't get more than like 12 hits, right?
That's all right. I'll get to 1 million eventually. All right. So vector is one quantity, right? What's the other quantity? I'll leave a little space here because we're going to have some examples of vectors here in a second. Does anybody remember the other quantity? The other thing. Okay, is every measurement a vector? Really? Because a vector has magnitude and direction, right? What's one example of something that has a magnitude and a direction besides the evil character? What? A ball rolling. What about that ball rolling has magnitude and direction? It's what? It's motion. What do we describe motion with? Inertia. Nope. Inertia is the resistance of change in motion. Speed? Velocity. Good. Velocity is something that has both a magnitude and direction. Does speed? No, speed just has a magnitude. So speed isn't a vector, it's the something else. Okay. What else has both a magnitude and direction? Oh, sorry, velocity could be like 2 meters per second east, right? Magnitude and direction. What else has both magnitude and direction? Momentum, good. Can I remember that from your context-rich problem, which we need to make sure we turn in today. Okay. Momentum has both magnitude and direction. Okay. Remember, momentum is the P, right? And draw vectors on the S because I don't want to confuse you. Okay. What else has magnitude and direction? Displacement. Man, you were like on point with these. Your physical science notes out? You just remember them all? Bill Nye the Science Guy, Ian Corlett Physics, just a little bit. Okay. What else? Guys, what else has magnitude and direction? Dancing with the Stars does not have magnitude or direction. They all go around in circles. Okay, I thought so too. Anything else? Okay, what's something that doesn't have direction? Okay, speed doesn't have direction, acceleration does have direction, because you're changing velocity. Okay, speed doesn't have direction, anything else? Mass doesn't have direction, right? You are like 50 kilograms. You're not 50 kilograms to the left, right? You're just 50 kilograms, that's your mass. Anything else that doesn't have direction? I did spell displacement.
It looks like a PH.
D-I-S-P-L-A-C-E-M-E-N-T.
You got it right.
You have to write it clear.
Maybe your vision has issues.
I have 2015 vision.
I have 20/20 vision. You want to do a bench press next?
I have 2 for 2.
Mine's
bigger than yours.
Jimmy, shut up.
Alright, so what else has no direction? So we said mass, we said speed. We'll get to displacement later. Okay? These are just examples of things that are
I was
vectors.
asking about, like, what did you say about the word again?
Yep, if you see in text, like in a book or in a worksheet, if you see a bold letter, then that means the vector. If you see a letter with an arrow on top, it means it's the vector. Okay. Anybody remember what that thing is called? Yeah. It's called a scalar.
Oh, yeah.
Oh,
I remember
Yeah. So a scalar is a quantity that has only what?
Either direction or magnitude.
Just the magnitude. So a scalar is a quantity with, like, what am I saying? A quantity that is only, not with, sorry, that is only a magnitude. So scalar is. So we had some examples of this. What were some examples of scalars? We said mass, right? So some examples. We have mass. Right. What else did we have? Speed.
Distance.
Distance. Anything else? Volume. As the loudness of the speakers or the amount of substance, the amount of liquid? Amount of substance. Okay. Anything else? A Newton? What does a Newton measure? Nope. Newton measures force. Forces have directions. Okay. Jose, what'd you say? That E word you said? Energy. Energy has no direction. Anything else? The weathermen talk about this one a lot. Temperature has no direction. What? Right. Temperature can't go anywhere. We can't say it's 35 degrees Fahrenheit south. We could, but we'd just be silly. Okay.
Temperature cannot move. What has no direction?
The temperature does not have a direction though. It's just the value. Right? So scalars, guys, are just numbers that just have a value. Measurements that just have a value, like the mass of something, the volume of something, how much energy it has, the temperature. It's just the value. And there's no direction. Alright? Vectors are ones that have a direction. Okay? So velocity, momentum, force, anything that has a direction tied to it is a vector. Okay. Are there any questions about that? Any questions about vectors?
Yeah, I do. So it doesn't. So a vector has to have both direction and magnitude.
Has to have both direction and magnitude, yep.
So if it doesn't have magnitude, then
If it doesn't have magnitude, then it's just a direction. Just to the left. Right. If it's just the magnitude, then it's a scalar. Okay? That's why I showed you that clip of this people me, because he says he has both magnitude and direction. Try to remember you need both of them. Alright? So, like on a test, if you are giving an answer that's a vector quantity, you need to tell me both the magnitude and the direction. Okay, does that make sense? Anything else? Trying to improve your vision? Alright. Anything else? Alright. Now, what if I have two vector quantities acting on the same thing? How can I figure out the total amount of vector quantity? If I have two vector quantities acting on the same thing.
Add them together.
Add them together?
Wait, so they have the same magnitude?
So, if I have more than one force acting on something, right? How can I figure out the total force?
Add them together.
Add what together?
The two vectors.
The two vectors. How do I add vectors together? We use a plus sign. So if I want to add two vectors together, right? Nan, don't write this down. I'm going to add some stuff to it, okay? Don't get mad at me again.
You're supposed to put that over there so they're under vector, so that one is.
Oh, I'm sorry. Okay. I forgot to erase everything, my bad. So, if I want to add V1 to V2, I just put a plus sign right here, Kevin. I'm good?
No.
Now you draw a bigger arrow to the center.
I draw bigger arrows.
Yes.
So how do I add them together?
You gotta know the distance.
No, we don't.
or you just add.
We just add? Okay, we'll get there. Alright? So, vector addition. The way we add vectors is we use something called the tip to tail method. Okay? And it tells you exactly what you need to do. Now, every vector has a tip, and every vector has a tail. So, if I draw a vector, here's my vector. Okay? Where's the tip?
At the tip of the arrow.
The tip of the arrow. This is the tip. Where is the tail?
At the back of the
Back. Right? The tail is where it's coming from, the tip is where it's going. Does that make sense?
Yep.
Okay. So now if I want to add V1 and V2, the way I add them is I need to take the tip of one vector and put it where?
On the tail of the other.
By the tail of the other. Okay? Now the cool thing about vectors is vectors are movable quantities. I can take V1 and I can move it around. Think about it this way. If this was a big touchscreen computer, right? I could like highlight this, copy and paste it, right? So vectors work that way. I can highlight this, I can copy it, and I can paste it over here if I want it right there. Okay? I can take this vector, I can do the same thing, I can copy and paste it. Okay, thank you for computer noises, guys. Okay. So if I want to do V1 plus V2, and I forgot my little arrow hats. Sorry about that, little arrow hats. Okay. If I want to do V1 plus V2, that means I need to take either V1 or V2, doesn't matter which one I start with, and I need to draw it basically the same way I have. Does this look identical to that one? Is it close enough?
And the bottom one's slanted and kind of pointed down.
Okay. If you're that nitpicky on my drawings, I'll be that nitpicky on your test questions. Okay, is it close enough, Michael?
Yeah,
That's what I thought. Alright, so here's V1, right? There's V1, right? So now I'm going to take V2, and where am I going to put V2? In front of V1, so that the tail of V2 is where on V1? At the tip. Yes. So now I'm using the tip to tail method, and I'm adding those two vectors together.
Then you want us to redraw it?
Okay. So then that's the resultant. Okay. The resultant vector is the resulting vector from vector addition. So the resultant vector is the resulting vector from vector addition. Sounds kind of redundant, right? I love it when they have the definition is basically the word, right? The resultant vector is your result, right? So now, where did this whole vector addition process start?
In your classroom.
In here, okay, good. But on the board where it started? At the tail of which one? Started at the tail of V1, didn't it? That's the one I started with, right? Now where does this whole process end?
At the tip of V2.
At the tip of V2. That means my resultant vector starts at the tail of V1 and points to the tip of V2. Okay? And resultant vectors usually get a symbol of R with a line over it, with a vector hat.
So we can add anything. Technically.
You can add any vectors you like now, Olivia. Okay? I've now empowered you to add anything you want.
So basically, that's all you do is you draw a line under it, the same length.
Of the two put together.
Oh my god.
So really all you do
Now
is
watch on the test. I'm gonna be adding like triangles and stuff. It's gonna be like so different from what we learned.
If they're triangles, they're not vectors. Okay. Alright. So, this right here, guys, this was V1 plus V2. Right? Equals that.
Wow.
Does that make sense?
So it better be like that on the test.
Now, those of you that don't have two colors, maybe you want to dash the resultant, so that way it kind of draws more attention to it. Okay, so that way it kind of sticks it out a little bit. Any questions? Any questions? Let's say I had a third vector in here.
Third one.
And you just
No.
We're going to have V3 go that way. Okay. So, let's try V1 plus V3. Okay. V1 plus V3. So I need to do that whole copy and pasting again, right? Right? So I copy V1, and I bring it over here. Now, do I have to start with V1 or can I start with V3?
You can start with V3 if you fancy.
I could start with V3 if I wanted to too. It doesn't matter which one I start with. So I'm going to copy V1 and I'm going to bring it over here. How's that look?
Looks
No,
like a D1.
that's horrible.
Okay, maybe it's a little long. I think that was a little long.
Should have had a D8.
No, it's not hit you in the head. Okay. All right. Michael, is that good? Number 20, is it good? Okay, good. All right. So I bring V1 over, right? Okay. Now I bring an identical V3 over, right? An identical V3. Now if I draw it so my tail of V3 is on the tip of V1, I'm going to kind of have a mess up here, aren't I?
Just do it, Branch.
So,
That's how it goes.
So Would you put it on the opposite side?
Nope.
No?
No, because I put it here, then I'm at with the resulting vector that's really long, and then I'd be doing tail to tail, not tip to tail.
Just overlap it, it's okay.
So I'm actually gonna put just a little bit below it,
Oh, you got it.
like that. So there's V3.
I thought I had it figured out.
Okay? You can overlap them if you want, but it makes it difficult for me to see what you did.
There's an arrow pointing that way and an arrow pointing that way.
Wait, so why did
you
it
got the
difficult?
V3.
I don't know. Alright, so then my resultant.
Is this like adding like this?
So my resultant now starts where? Not at the tip of V3. Starts where?
Right?
Where did I start?
I feel you.
I started at the tail of V1, right? So that's where I start with my resultant. My resultant starts at the tail of V1 and points to where?
The tip of V3.
The tip of V3. You want to start at V3. Okay. So this right here, that little green one right there, that is my resultant.
Wait a minute. Rewrite the result.
Okay. We start where we started. Okay. So we started at the tail of V1, right? And we ended at the tip of V3. So my resultant starts at the tail of V1 and ends at the tip of V3. Okay? So that's my resultant. Alright? And now, like I said earlier, if you are writing just in pen, maybe you want to dash your resultant so it sticks out a little better. Does that make sense, guys?
No.
And girls? No, what doesn't make sense, Kyle? Oh my goodness, it is like September. Hey, we have Halloween and Thanksgiving before we got to start seeing Christmas carols. Alright? Alright,
You ever heard of Halloween?
let's try this. V1 plus negative V2. What does that negative do?
Uh-oh.
Makes V2 go which way?
The other direction.
The other way. Okay? So, we take my V1, my identical V1 from over here, right? Do that one along again.
No, it's fine.
You just want me to be very lenient now, don't you?
No, I think it's a beautiful branch.
Alright, thank you. I appreciate compliments, but it doesn't help your grade. Alright, so, only laughing at my jokes helps your grade. That wasn't a joke, Olivia. That actually decreased your grade. Alright, so V1 goes that way, right?
Yup.
Now if I'm adding negative V2, now V2 starts here, but if it's negative, what do I have to do to it?
Turn it, flip it.
Flip it the other way. So it's an identical vector, except it points the opposite way.
Okay.
Branch.
We just do that.
Are you gonna put the negative
Why couldn't you
sign
just put V1 minus V2? Instead of making it a negative V2.
Because with the signs, with vectors, the sign says the vector points the opposite way. So I'm being very intentional with making sure I put a negative sign by the V2, because it's telling you, take V2, but point it the other way.
Why didn't we do
What? Because V3 is longer than V2.
So what would it be if it was just mine? The same thing?
It'd be the same thing. Okay. So now, to find my resultant, we start where we started. We started at the tail of V1, right? And we ended at the tip of V2.
Who's like that?
What?
Who's saying that? Yes.
Okay. Okay. So there's my resultant. Does that make sense, guys?
it? So it's like
Ah, good question. Katrina says, why don't we start putting numbers? So let's call this one 4. We'll call this one 3. We'll call this one 1. Okay? All numbers do is they let me start putting numbers with my resultant. Okay? So here, I did 4 plus 3, right? 4 plus 3.
Yeah.
Alright, my fault, not 3. 4 plus 1. Sorry.
Yeah.
Way to go.
Okay? So that means my resultant equals 4 plus 1, which is 5. So the magnitude of my resultant is 5. The total vector would be 5 to the right.
And like if there's numbers during the test, do you want to just like draw all this out, or you just add the numbers?
Okay.
That's not so-
If I say to graphically find the answer, you need to draw the vectors with tip to tail method. Okay? Alright, so on your test that's coming up, you will be required to draw, not just do the addition. I know we can add. Okay, you guys are in You guys are juniors and sophomores in high school. You can add. I understand that. All right. Yes, Money.
Will we ever get one like V1 that would plus V4, for example, going down?
We could. We'll get to that. Don't worry. Okay. Get a lot out of some money. That's all right. Okay. Now it's good to be curious. I like that. All right. So now V1 plus V3. Okay. What do I do here? V1 points to the right. V3 goes to the left. So what do we know about these ones? Are they adding them or subtracting the numbers? Subtracting. So the result in here is going to be 4 plus negative 3 because 3 and 4 go opposite directions, which makes what? 1. So the resulting here would be 1. And for this one, V1 and V2. V1 is still 4. V2 is 1. But now it's negative V2. So it's 4 plus negative 1, which is 3. The resultant would be 3.
I can see it from the side of my.
Right. Does that make sense, guys? Is it really? I don't think it is. I think sarcasm is probably the most complicated thing you ever learned. What?